All right, guys, let's get started. For 7. Okay, 7 should be pretty simple actually. They tell you the formula PF equal to E times PD. They give you that E is equal to 5 halves. What does that mean if it's 5 halves? If it's greater than, it's a hyperbola. You should. It helps, like with the tables and stuff. But so you should know that. And it tells you that one of the foci is 2, -3, and the directrix x is equal to +1. So if you were to graph this, this is our directrix. Our foci is 2, -3. And if you were to choose a random point P, make it x, y, we have a line going to PF, and a line going from point P to the directrix. The distance from P to F is just the distance formula. So it's x minus 2 quantity squared plus y plus 3 quantity squared equal to 5 halves, which is E, and the absolute value of the distance from P to D, x minus 1. And if you can write this, it's just essentially simplifying. We square both sides and then we factor the inside, so we have x squared minus 4x plus 4 plus y squared plus 6y plus 9. We square the right side, so we have 25 over 4 times x squared minus 2x plus 1. And then you simplify. So just by any way of simplifying the x squared, we have the coefficient of 1 minus 25 over 4 plus x times -4 plus 25 over 2 plus y squared plus 6y plus 13 minus 25 over 4 equal to 0. Everyone got that? And then it's just continuously simplifying that. In the end, your answer is -21x squared plus 34x plus 4y squared plus 24y plus 27 equal to 0. And they ask that you don't need to put it in standard form, so you can leave your answer like this. And this is worth 6 points. So all of you guys should get this question correct. Yes? For the next one, they gave us a graph with limits. By limits, I mean like the lower and upper limit. They want us to find the volume of that, and they tell us that -x squared over 4 plus y squared minus z squared over 4 equals to 1, comma y is between -√5 and -√2. And since the surface is facing this way, its radius from outward would be a function of the square root of x squared plus z squared. Can you guys all see this? This? We will. Yeah.
So which way is the quadrant surface facing?
So this is the side, and it's facing this direction. Its center being at y axis, essentially. But it has limits with y. Okay? So if we were to find our dv is equal to pi times radius squared times dt. Essentially, this becomes dy. Oh, yeah. How we found r? R is facing this direction, so r squared is equal to the face which involves x squared and z squared. R squared is equal to, like, mostly it's like x squared plus y squared, but since it's facing this direction, with the flat surface being a z and an x axis, so it's x squared plus z squared. What? Yeah. It's facing in the y axis direction. Do you guys all see that?
Yeah, it's fine on the x facing.
So we're good to continue? Well, you're not putting a 0 in here to get this formula. This is just looking at it and seeing we have a circle here in the x, z, and then y is coming outward. So the radius is a function of x and z. Did that make sense? Did you have a question? Okay. Let me just continue with this problem. Maybe it'll be a bit more clear, and we'll get back to it. We want this formula to be in terms of y to integrate it, since we have dy. So we solve this equation essentially for x squared plus z squared. So we get x squared over 4 plus z squared over 4 equals y squared minus 1. You multiply everything by 4. Therefore, x squared plus z squared is equal to 4 times y squared minus 1. And then we make that substitution in here. So I'll say this again, but you're solving for x squared and z squared to substitute it in here in terms to get it in terms of y, so that we can integrate it. You guys have it copied?
No.
So was finding the r the confusing part? Yeah. I don't think that would give you anything different than that. In Calc 3, you'll do crazy stuff with this. Like, not even imaginable stuff. Okay. Are you guys good with this then? Can I move on? Yeah. Yeah, 4. Because you're just solving for x squared plus z squared. So then our v is equal to pi, going from negative square root of 5 to negative square root of 2 of 4 times y squared minus 1 dy. And this you guys should be able to integrate. Do you want me to go through it all?
Yeah. Always.
Okay. So we have 4 pi. You do the integral of that, you get y cubed over 3 minus y, going from negative square root of 5 to negative square root of 2. That's equal to 4 pi times negative square root of 2. Negative square root of 2 cubed is 2 square root of 2. Negative. Minus the negative square root of 2. You guys all see that? The square root of 2 cubed is 2 square root of 2. Minus negative 5 square root of 5. If I take out a square root of 2 from here, I have negative 2/3 plus 1. I took out a square root of 2 to simplify that. This is equal to 1/3, so we have square root of 2 over 3. In here, we sort of do the same thing. We take out a square root of 5, so we have 5/3 minus 1. And we change this to a plus everything. So we are left with, this would be 2/3, so it's 2 square root of 5 over 3. So this is just simplifying. So then the answer is 4 pi times square root of 2 over 3 plus 2 square root of 5 over 3. And then you can take out the divide by 3 if you want. So this you guys could do in your sleep. That's an integral. Yeah.
I would need to wait. What's your left right?
Are you talking about this? So I plug.
You put negative square on the bottom. Like it's what's your left right? Always have a negative square to the bottom. Is the limits?
Oh, well, this is the smaller to the bigger limit. Yep. So are you guys good with this part? Going back. So with this part, you guys should have, okay. So normally to find equation of a circle, you have x squared plus y squared equals r squared, right? This is the same thing, but our circle is facing on the gx plane. So then the square root is x squared plus z squared equals r squared. And then r is equal to the square root of that. So then pi r squared dt equal to dv. Yeah.
mathematically, like you're supposed to say, oh, this is like a circle and not some other, but there will be drawn out so you can actually see it better.
But how would you find the radius of an ellipse? Because it changes. I mean,
So you just assume it's going to be a circle.
I never want to say yes to these questions because they can do weird stuff. But it would be where the math would work out. Like on all the problems, the math normally works out. So if you remember the formula, well, actually, if you don't have a circle, it's not pi r squared t. So in my experience, I will say it will be like a hyperbola, like shape like this. So it might be a circle, but this be weird, but they might have two of them. And if it's exactly symmetrical, you can multiply by 2 or be in the mindset where you may have to do stuff like that. Okay, did that make 7 points? But if it is a circle, do you guys understand all of this? Yeah?
Do the limits take care of like the whole, it's facing to the left instead of the right?
I mean, if they might give you 2 limits, or if you can tell that the distance between both limits is equal. So like, say if this was from -1 to -3, and this was from 1 to 3, they'd be symmetrical and they'd be equal. Are you guys good to move on? All right, I'm gonna erase this. So the next one, we are given the equation x squared minus 5x1 plus 13y squared minus 5 equals 0. And they ask you to find sine alpha and cosine alpha. Okay? There's just essentially one main formula you have to remember. Cotangent of 2 alpha is equal to a minus c over b. Okay? If you remember this and you know which is a, b, and c, then you can solve this whole problem. A is going to be the coefficient in front of x squared. So in this case, we have 1. C is the coefficient in front of y squared. So it's minus 13 divided by b, which is a coefficient in front of xy. So it's divided by -5. So we have -12 over -5, which is equal to 12 over 5. If we were to graph this, we would have angle of 2 alpha. Cotangent is adjacent over opposite. So adjacent is 12, opposite is 5, and then the hypotenuse you get is 13. That should all make sense. Therefore, so we can get that cosine of 2 alpha is equal to 12 over 13. But that's adjacent over hypotenuse. And then you just use the formula. Sine of alpha is equal to the square root of 1 minus cosine of 2 alpha divided by 2. That's equal to the square root of 1 minus 12 over 13 divided by 2, which is equal to the square root of, just equal to 1 over square root of 26. Because this is equal to 1 over 13. And that's, so essentially that's just plugging in a formula. Cosine of alpha is the same thing. It's 1 plus cosine of 2 alpha divided by 2, which is square root of 1 plus 12 over 13 divided by 2. That's equal to the square root of 25 over 26, which is equal to 5 over square root of 26. And this problem is worth 7 points as well. So you guys should definitely get all these points. Yeah.
Is that a 1 over radical 26 or just a radical 26?
1 over radical 26.
It's not even like a. No.
So any questions on this problem? Yeah.
When you just showed the cross-sectional curve, is that,
What do you mean?
like, is there anything else we have to show?
No, that's all you need. You have your sign. Okay. Yeah. Yeah. Okay, guys. Let's move on, guys. For 10, they tell us the formula 12 times x plus 2 quantity squared minus 5 times y minus. Did I say a 3 or a? I think it's a 3. It's a 3. Yes. Squared minus 12 squared. Yeah. Times 5 squared equal to 0. Yep. First, we have to put that in standard form. How do we do that? Isolate those essentially, so we get x plus 2 quantity squared. You guys want me to show? I'll show you guys. 144 minus 25 times y minus 3 quantity squared equal to 144 times 25. You always try to get equal to a 1, not the other way, by dividing by 144. So this ends up being x plus 2 quantity squared divided by 25 minus y minus 2 quantity squared divided by 144 equals to a 1. You guys good with that? What? for, what would our A value be? 5. Our B value? 12. What shape is this going to be then? A hyperbola, which kind? Horizontal hyperbola?
Excuse me,
Yep.
in the homework, I was getting that kind of confused with the A and B. Like one problem said A has to be bigger, so then I showed us A has the bigger one, and then turned out to be wrong, another problem. Like how can you determine which one is A? Which one's X? Like,
Yeah.
if you could take X squared.
It depends, but I think they want to do it like,
Like if it's for a
No,
list,
it's exactly why-
Yeah.
Yeah, give her an explanation.
okay. For, she had a very good explanation. You want to say it?
For an ellipse, it's, which is gonna be like the x plus 2 plus 1 minus, it's gonna have the plus, not the negative, it's gonna be, the A is gonna be bigger. But if it's for the hyperbola, you're gonna figure out, Jefferson constant sign, the A's.
So, do you guys all hear that? Or I'll say it again. And then ellipse, it's the bigger one. So A is the bigger denominator, and that's your A value. For a hyperbola, it's whichever is the positive, so it's minus something over the B. Okay, and it's in this problem, A is under X, so it's a horizontal. Yeah.
I noticed that A is often small to B, but under tree.
They put no great answer.
Okay.
So,
For C, the formula is A squared plus B squared for a hyperbola. So that's 13 in this case. C, that's given. What's the formula for E?
A over
C over A for this. So this is 13 over 5. Our big X is, do you guys want to say it? X plus 2, because essentially it's in the parentheses. So our little x is big X minus 2. Big Y is equal to Y minus 3. So little y is equal to big Y plus 3. Are you guys good with that? Okay. And then you use that information to fill out the table. So with big X and big Y, what's the center? 0, comma 0. And we make that translation to get the center for X, comma Y. So it's going to be what? -2, comma. That's essentially plugging in a 0 here to get X and Y. And essentially you do that for everything. So for foci, they gave us a formula plus or minus C, comma 0. So for this, it will be what? Plus or minus 13, comma 0. Now, we will have two foci since it's plus or minus. So first we put in a 13, a positive 13. So we get what? 11, comma 3. And nothing is changing in the Y position. We put in a negative 13, so we get a negative 15, comma 3.
So you said they'll give us the plus or minus C?
I believe they will, because in class they showed that table and that had it. But it's essentially for horizontals, plus or minus C, comma 0. For vertical, it's 0. So, do you guys have trouble with these tables, or they seem pretty?
It's just everything they give us is all big X and Y.
Yeah, we do so big X and big Y is essentially if it was at 0, 0. So then we need to translate it to get the coordinates for anything else that's somewhere else. So for vertices, it's plus or minus A, comma 0. So we have plus or minus 5, comma 0. Again, the 3 for the y position stays the same, but 5 minus 2 is a 3. Negative 5 minus 2 is a negative 7. So that one is pretty simple. For asymptotes, do you guys know the formula? Yep, plus or minus b over a times big X in this case. So we have plus or minus 12 over 5 big X.
Why is it big X?
Because we're right now looking at big Y and big X. And then we convert that by plugging in what big Y is equal to and what big X is equal to. And that sort of involves some math which you have little time to do, like the little algebra steps. And it does get messy there. I'm not sure if that will be given to you. Check if it's on that table. That's not? Okay, so you guys should just remember that. But in order to convert it back to little x comma y, big Y is equal to y minus 3 equal to plus or minus 12 over 5 times x plus 2. Do you guys see that? We made the substitution where the big Y is and where the big X is. So then now we have to solve these two to get our equations. So then Y is equal to, first of all, a positive 12 over 5 times X plus, so this would be a 24 over 5 plus 3 times, what, 5, 15. So you get 39 over 5. So this is some math that you'll need to do. And then negative 12 over 5 X minus this time. So you have minus 24 over 5 minus 15. If I said that right. No, plus 3. So it's still plus 15. So you get minus 8 over 5. You guys all see that? No, because
Oh, I see what you're
yeah, it's still minus 24 plus 15. Yeah. So they'll ask you only the things that apply. So if it is a ellipse, they won't have asymptotes there. It'll just be like directrix.
For the aspects, actually, A would be plus minus y.
Oh, you're asking for the formula?
Yes.
I'm not sure what the formula is. It's given.
Because he shows like a chart chart.
Good. So what is the formula? Do you guys want to read it out? Is it just,
For the other aspect?
yeah.
It's you switch the A and G. Yeah.
So you guys are saying
Yeah.
that? Okay. So that's the formula for vertical hyperbolic asymptotes. And so you guys are saying they give you that. So you have to be careful which you use, because the information is like, flips easily. So you have to be able to recognize. You have to be able to recognize that this is like a horizontal hyperbola, so you use those information. And then for the directrix, the formula for this time is big X equal to plus or minus A over E. So it's equal to plus or minus 25 over 13. So then we have X plus 2 equal to 25 over 13 plus or minus. Yeah. You guys can't really see that clearly. So then X is equal to negative 1/3, 1 over 13, and negative 5 over 13. Yeah. So big X is equal to plus or minus 25 over 13. So small x plus 2 is equal to plus or minus 25 over 13. So then when you solve that, x is equal to negative 1 over 13 and negative 5 over 13.
Yep.
Do you?
Memorize X plus
For directrix? It might be given to you. Do you have a question?
Yeah.
Negative 1 over 13 and negative 5 over 13. What?
Do you need P for that as well, or find a different shape?
What do you mean? P?
Like, it's on the homework, I believe it was a negative P equals, or negative P0 for the, or it was like.
Okay, then in that particular problem, they were trying to show that the point was on the directrix. So that's why the information worked out that way, probably. For an example like this, where you don't have a graph, you need to use the equation to find it. And if you were to draw the graph, you'd label it that. Are you guys good with this problem? See? For number 11, you sort of do the same thing. Now, I don't think your exam will have two problems like this. There will probably be one, and then some other thing. But for this one, they do have two. So we have 5 times x minus 5 quantity squared plus 3 times y plus 3 quantity squared minus 5 squared times 3 squared equal to 0. To get into standard form, we have 5 squared times x minus 5 quantity squared plus 3 squared times y plus 3 quantity squared equal to 5 squared 3 squared. We always try to get 1 at the end, so we have x minus 5 quantity squared divided by 9 plus y plus 3 quantity squared divided by 25 equal to a 1. Now this is an ellipse. What ellipse is it? Vertical or horizontal? Vertical. What is your A value? 8 is 5. And B is 3. The formula for C is A squared minus B squared. So you get square root of 16 equal to a 4. What is your E value? B over A. So that's equal to 4 over 5. E, you should know what E is. I'm not sure if you're given. In general, you should know what E is if you're given. I don't think so. Your capital X is x minus 5. So your little x is big X plus 5. So capital Y is y plus 3. Your small y is capital Y minus 3. Make sure you label your capital ones first. Make sure it's obvious which is which. So since an ellipse can't have asymptotes, they'll ask you for the ends of minor axis. So the center at capital X and Y is 0, 0. The center at little is going to be what? Yep. The formula for foci is since it's vertical, 0, plus or minus c. So we get 0, plus or minus 4. So then on the right we have 5 stays for the x values, but it's -3. So it's 4, -3, 1, -4, -3, -7, and 5, -7. For vertices, 0, plus or minus a. So it's 0, plus or minus 5. So then we will have 5, positive 5 minus 3. So that's a 2. Positive 5, -5 minus 3 is a -8. So your coordinates will be 5, 2, and 5, -8. For ends of minor axis, you have the formula plus or minus b, 0. So we will have plus or minus 3, 0. Again, it's just adding now and stuff. So 3 plus 5 is 8, -3. -3 plus 5 is a 2, -3. That's simple again. The formula for the directrix in this case is capital Y equal to plus or minus A over E. So it's equal to plus or minus 25 over 4. You guys catch that? It's plus or minus A over E. So it's 25 over 4 plus or minus. So then we make the substitution, little y plus 3 is equal to plus or minus 25 over 4. So then we have little y equal to positive 25 over 4 plus 3, which is
it 5 over 4?
minus 3. What?
Is it plus or minus 5 over 4? Is
Yeah.
5?
No, it's it's because E is 4/5. So let me show that. Yeah. Good catch there, yeah. So the reason it's 25 over 4 is because it's A over E, which is 5 divided by 4/5. So then when you do solve it out, you get y is equal to 13 over 4 and -37 over 4. So y is equal to 13 over 4 and -37 over 4. Yeah, I think so. Yeah.
Yeah.
In this? Oh, it depends on what you have. This is a vertical ellipse. So then, if you were to, well, for that, it'd be y equal to, because the directrix is with the major axis, so it'll be a top and a bottom. So, again, to me, problems like these are just fill in the blank. The only thing that can get confusing is, again, with like the asymptote, where you quickly have to do the math. But, again, so this problem was worth 9 points. I mean, so you should get most of them.
Our hyperbolas are all asymptotes.
Yeah, for those they'd ask asymptotes, or ellipses they'd ask major or minor axis. erase this? Yes. So the last one is with traces. So where's the formula? Okay. We are given the surface x squared minus 4y minus 9z squared equal to 0. We have to put it in standard form. You want to always put your quantities that are the second power on the same side, so we can do x squared minus 9z squared equal to 4y. Simplify this, so we get x squared over. What do we simplify by? You guys want to say? What should we simplify by? 30. We divide by 36. Okay, to get everything. So the letters don't have a coefficient. So then we have x squared over 36 minus z squared over 4 equal to y divided by 9. So then the letters don't have a coefficient. That's what I'm. You try to get the x squared, everything that's to the squared power to the one side. If y was squared, then yes, you get it equal to a 1. So yeah, if we had everything squared, you try to get it equal to a 1. But since we have one variable which is not, and then it's just essentially looking at all the equations in your mind and trying to find what this shape looks like. Okay. So, what judge it just by looking at this? What do you guys notice about it? It has a minus, so we know it's something with hyperbolic. And then, can you say something? Someone said something. I heard it. It's a paraboloid because you remember the equation. Okay. What time is it? Okay, we've got time. I'll go over the equations. Not really memorize them, but somehow understand them. They're not given. All right. I'm gonna go over the equations. This is not a legitimate way of knowing which shape is which, but essentially, I'll just go over the things that I noticed, and then. Yeah, but still, I don't understand how it does. Okay. So one thing that you have to notice is if there ever is a minus sign, it's a hyperbolic. So there is a minus sign in this, it's a hyperbolic. When you have two variables equal to a 1, it's a what? Cylinder. Now, if we had a plus here, what would we have? An elliptical cylinder. So if you have two variables equal to a 1, it's an elliptic because it's a positive sign, and it's a cylinder because you have two variables equal to a 1. Okay? If there's a minus sign in here, it's a hyperbolic and you have two variables equal to a 1, it's a cylinder. Okay? Keep that in mind. Yeah. If we have x squared over a plus y squared over b plus, or let's set it equal to a variable that's not squared. Now, we have a plus sign in here, so we know it's something with like elliptical. When you have three variables and it's equal to the variable without a power, like z doesn't have a power here, it's a paraboloid. Okay? Yeah. Now cylinders have two variables. So looking at this, we have a minus sign, so it's hyperbolic. And then we have equal to a variable that's not to a power, so it's a hyperbolic paraboloid.
Oh, well, we are how we.
Yeah, did that make sense? Okay. Moving on. Okay. If we have three variables equal to a 1, are all the signs positive?
Yes.
So it's an ellipsoid. It's an ellipsoid when you have three variables that are squared equal to a 1. Okay? If I change one of them to a minus sign, so there's one minus sign here, okay? So it's a hyperboloid of one sheet. Did you guys see that? There is a minus sign, so we know it's not an ellipsoid. And since there's one minus sign, it's a one sheet. If there's two minus signs, it's a hyperboloid of two sheets. Yeah.
Can you explain like what the sheet means?
It's it's like in the picture, when it's like one sheet. I believe the picture is like this. Yeah. When it's two sheets, it's like that. So it's just a different ways that shapes look. I might not be completely right about that, but so did that make sense? If there's one minus, it's one sheet. Two minus, it's two sheets. And then the last one is a cone. That is when all the variables are squared and it's equal to the other one. Okay? So there would be no way to get this equal to a 1. So your option is to have a minus on the inside, but you can bring it to the outside. So then two variables added equal to v squared. That is a elliptical cone. Now, here's the question. If there is a minus sign and you have a hyperbolic cone, I don't think there is such a thing. Do you guys know if there is such a thing as a hyperbolic? Probably not, right? But then you'll have a minus z squared. So, okay, we'll just leave it a positive elliptical cone. So going quickly over them, did they make sense to you? Yeah. So this is on the review. Yeah, but it's in 3 dimensions. We're looking at it in a 3D perspective. So you have to say it's a cylinder.
Okay, so 2D.
Yeah, I mean, a cylinder is a circle over time. So are you guys good with these? These are on the review. I just wanted to quickly say all the different ways, although these are not the legitimate ways why the shapes are their shape. Okay, let's do the traces quickly, and then you guys can leave. With the x comma y trace, what is equal to 0? So you plug in 0 here in this equation. So we simplify it, we get x squared equal to 4y. What is this? A parabola. Normally we have, yeah, so this would be a parabola. You could have, yes you do, to get to this, yeah. Normally you could have like x equal to 4y squared, and then that'd still be a parabola. Yes? XZ trace. What is equal to 0? Y would be equal to 0 here. So then you have Z equal to plus or minus x. Okay. If we plug in a 0 here, you solve for one of them, then you'll have a plus or minus of the other variable. Okay? Now what is this formula? A line, but we have 2 lines. Since it's plus or minus, we have 2 lines. Okay? Looking at the YZ trace, what is equal to 0? We make x equal to 0 here, and then you solve for, so we can solve for y or z, but we get z squared equal to -4 over 9y. What does this look like? This is a parabola again. Last one. Y equal to plus or minus 9. So that means we plug in plus or minus there. We get x squared over 36 minus z squared over 2, sorry, over 4 equal to plus or minus 1. Now this required looking at the equation and seeing what is going on. We have a minus sign here, so we know it's a what? Hyperbola. And it's equal to a 1, so it's plus or minus, so it's 2 hyperbola. Did that make sense? The traces is just plugging in what they tell you. Yeah.
So hyperbola, like, I thought it was already 2.
What do you mean?
Like, I thought a hyperbola was 2
Yeah.
shapes.
But then we have plus or minus of it.
So we have 4 like these.
Yeah.
Okay. Just want to make sure. Like,
Yep. Yeah, that's it.
So when is it a
Yeah.
null?
When it's a what?
A null?
It's like when there's no trace.
Yeah.
So,
There are those.
it's when it equals like -1, right?
When it's equals what?
Like when it's like that for like x squared plus x squared equals -1. It's like normally
When you can't get into a shape or yeah, that could be a null.
that's usually what.
Yeah. I would say stick with that. I'll look up more examples right now. But all right, that's